This video is a quick review of some updates that we've made to our free GitHub repo for deploying an end-to-end solution with 275 million rows of real data to your Fabric environment. It is one of the modules in our GitHub repo, which is linked in the description below. My name is Greg Beaumont, and you can follow me on LinkedIn or check out my blog. And I built the GitHub repo mentioned in this video along with my coworker, Inder Rana. And we've had this repo out for a while. Effectively, what it does is it reaches out to CMS. It gets 275 million rows of real CMS Medicare Part D data. It drops it into your lakehouse, cleans it up, models it, and then previously it deployed a Power BI report along with a Fabric data agent for the lakehouse or warehouse. We are now adding a second Fabric data agent for the semantic model. And the reason we thought it would be helpful to have two is you can compare and contrast how the two are different. You can actually run queries on both of them and compare the performance. And you can also see what the development process is like to make changes and modifications to either of those options. Also, the Fabric data agent for the semantic model will then work with Power BI Copilot, which is an added value. So within the Power BI report, the AI instructions that are baked into that Fabric data agent for the semantic model will be read by Power BI Copilot. And that's both at the report level and also when looking at the enterprise chat on your data capability, which is effectively a software as a service MCP server within the Fabric environment that you have access to. So there's two different ways to deploy this. We've run through this before and it's been out there a while. Many of you have probably already done this. The quick setup is recommended if you just want to get a environment stood up with 275 million rows of data, so you can have end-to-end demos and testing on different Fabric capabilities for a complete lakehouse build. And option two is if you want to go through a training process or a learning experience to deploy each step independently and understand how to configure them to best practices. If I go ahead and click on the setup guide for manual and walk down to step 5, which is for the new data agents, this is where the changes were made. There was originally this instruction for creating the lakehouse or warehouse Fabric data agent. Now there is also a process by which you can add AI instructions directly to the semantic model. And then there's also the instructions on how to go ahead and deploy that. And once it's deployed, you can test it either with the data agent or you can use Power BI Copilot or even better, standalone Power BI Copilot in the Power BI service for that MCP-like experience. Also at the bottom, there's some examples of how the query times compared between the two different data agents. You'll see that in general, with 275 million rows in this particular architecture, the Lakehouse data agent performed a little bit better than the semantic model data agent as far as how long it took to process the queries. These were very simple queries where it's a simple star schema with simple sums and simple divides. There was not any time intelligence or complex filtering criteria or the types of things that you might see in less simple semantic models. And in those scenarios, at some point, I would expect the complexity of the queries to run faster inside of a semantic model data agent than a lakehouse data agent. But that's for you to test and find out on your own. I haven't actually tested that at this point. I did create a smaller version of the semantic model to see if that improved the query times. And it did. Some of those query times were actually cut in half when I had a semantic model with just a few 100,000 rows opposed to 275 million rows. However, the Lakehouse data agent still performed a little bit better as far as the number of seconds it took to run the query. I did not do an analysis of how much compute was being used by each data agent. And if this is something where thousands of people in your environment are going to be using the data agent, that's probably something that you'd also want to evaluate. So now I'll just quickly walk you through what's new and what's been added to this repo in case you want to redeploy and try it again with the new offerings. If I go down to the semantic model, which again, all of this will be completely deployed by the quick setup in 30 minutes, give or take, and it'll be ready to go and everything will just work. But if I go to click on the semantic model and then up here in the upper right, prep data for AI, I didn't need to simplify the data schema because the columns that we didn't need are already hidden. The verified answers we skipped for now just because that references a Power BI report, and we figured that's something that you could add on your own. The AI instructions, though, are also available in the repo as a text file that you can cut and paste. But these instructions are very important. These are also the instructions that could be added to the data agent However, the data agent will read the instructions straight from the semantic model. So you can just paste them here. And this will instruct the agent how to construct queries that maybe don't map to an individual value, such as ACE inhibitor drugs contain pril within the generic name of the table named drug. So the word ACE inhibitor doesn't exist anywhere in the semantic model at all, other than in these AI instructions. But by providing these instructions, the large language model will be able to create an accurate query that filters for drugs that are technically ACE inhibitors. If I go ahead and move back to the workspace, and we have the traditional data agent, which is using the lakehouse or the warehouse, depending on which you choose to use if you're doing the manual install option. But now we have the semantic model data agent. If I go ahead and open that up, you'll see I haven't added any instructions because it'll read the instructions straight from the semantic model. I've checked the 5 tables over on the left, and then I've already run some tests on it, which you can see here in my chat history. So for example, if I ask show total cost by specialty in 2022, it will give me a breakdown of the top specialties by total cost in that year. And if we go back to the repo, you'll notice that I have 2 columns here for whether or not the results were the same from both the lakehouse and semantic model versions of the data agents, and if they were accurate. Now, they were always accurate. I never got a wrong answer in the testing that I did with these different questions, but there were some examples where they didn't give the same results. So for example, when I asked for top 10 providers in Dallas, Texas for total claims, one of the queries returned just the name of the provider, and the other returned both the name and the specialty. So there were some providers that had practiced under different specialties, and so the aggregations were different when the additional filter criteria was put into the query. So that's the type of testing that you'll need to do with these data agents, because there may be scenarios where you want it to be filtered by specialty and maybe you don't. And by modifying the AI instructions, you could perhaps provide a more consistent experience for those end users. So again, this was just a quick video to give you an update on what's changed with the repo. A link is provided at the bottom. You can use the repo for free, and it'll deploy that end-to-end solution to your Fabric environment with a fully functional demo ready to go in less than an hour. If you like this video, please give it a thumbs up and follow the channel. Thank you.